Hello and welcome to this video on permutations and combinations with me, Andy Duncan, here at Finlingo.com. Sean Wenger is a famous football manager being paid a measly £10 million a year to run a famous London football club. The season's about to start and he has all his positions filled in the first team except for the 3 strikers. So he has a goalkeeper, 3 defenders, 4 midfielders, but so far 3 striker positions to fill and 5 transfer targets to buy. The 5 potential players are a Scotsman, a Welshman, an Irishman, an Australian and a New Zealander. To justify his measly 10 million, Sean sneaks home, gets out 3 cups and 5 snooker balls and puts the balls into a purple velvet bag. He's going to randomly draw 3 balls and put them one at a time into the 3 cups to decide which of the 3 players to buy from his list of 5. This should keep all his supporters happy and make it look like he knows what he's doing. So what we want to know is, what are the permutations and what are the combinations of players and striker positions available? Let's do the permutations first. Any one of the 5 balls could go into the first cup, so that means there are 5 random possibilities. Let's just note that down. Sean puts on a blindfold, pulls out the red ball first at random and puts it into the first cup. Now there are 4 balls left and any one of the 4 could go into the second cup, so let's multiply that 5 by a 4. Sean randomly takes out the blue ball and puts it into the second cup. So now there are 3 balls left. That's 3 possibilities for the next draw. So let's multiply that 4 by a 3. At random, Sean pulls out the green ball. Now we can work out all the permutations there might have been for 5 different balls in 3 different cups. It's 5 times 4 times 3, and this is equal to 60 different random permutations. Notice there's a cunning mathematical trick we can sneak in now. Let's take that 5 times 4 times 3 and multiply it by a special number equal to 1, and that's 2 times 1 over 2 times 1. Now we rewrite the formula. So it's 5 times 4 times 3 times 2 times 1 divided by 2 times 1. And this is 5 factorial divided by 2 factorial. And this itself is equal to 5 factorial divided by 5 minus 3 factorial, which, amazingly, is the formula for permutations, which is equal to 5p3. Remember, we had 5 balls and 3 cups. So 5p3 equals 5 times 4 times 3 times 2 times 1 all over 2 times 1, which is equal to 5 times 4 times 3 once we do some cancellations. And this is equal to 60. Now we can write out the formula. That's npk equals n factorial divided by n minus k factorial. Sean takes off the blindfold and he's happy. There were 60 permutations he could have picked, and random chance seems to have given him a perfect selection that he thinks the newspapers are going to like. But now he gets his 3 balls to work out who should be a right winger, who should be a centre forward, and who should be a left winger. Through trial and error, he figures out that there are 6 permutations for mixing up his 3 new strikers. So that's red, blue, green, blue, blue, red, green, red, green, blue, red, and green, red, blue. But does it matter where they go on the pitch? Sean has a brainwave. He decides next season all his strikers will combine interchangeably and play anywhere across the front line. So he doesn't care about what order they came out of the velvet bag. So red, green, blue in any order counts as 1 combination. We'd also like to know the total number of combinations we could have had from the original situation with 5 balls, where it just doesn't matter how the final 3 get arranged in the cups. To do this, we need to work out the mathematical formula for finding out how many ways we could arrange the red ball, the blue ball and the green ball in the 3 cups. We empty the cups again and put the red ball, the blue ball and the green ball back into the velvet bag. Sean picks one out at random again. This time there are 3 possibilities for which ball could go into which cup, so that's 3 times. He pulls out the blue ball at random. Now there's 2 possibilities for what could go into the second cup, so that's 2 times. He pulls out the green ball at random. Now there's only 1 possibility left for what could go in the last cup, and that's the red ball. So there's the 1. So 3 times 2 times 1 is the number of ways 3 different things can go into 3 different slots, and it's equal to 6, just like we found earlier. And cunningly, 3 times 2 times 1 is also equal to 3 factorial. So if we divide the number of permutations by this, we should get all the interchangeable combinations where the precise order of the final 3 things just doesn't matter. Remember, the formula for the 5p3 permutations was 5 factorial divided by 5 minus 3 factorial. If we change that now to 5c3, that's going to be equal to 5 factorial divided by 5 minus 3 factorial and also divided by 3 factorial. Now we'll have the total number of striker combinations that we could have had, which is 5 factorial divided by 2 factorial times 3 factorial, which is 5 times 4 times 3 times 2 times 1, divided by 2 times 1 times 3 times 2 times 1, which is 5 times 4 divided by 2 times 1, which is, finally, 5 times 2, which equals 10. We can write that out formulaically too. So that's nck equals n factorial divided by n minus k factorial multiplied by k factorial, which even more amazingly is the formula for combinations. And just to recap, the formula for permutations is npk equals n factorial divided by n minus k factorial. Fortunately, Sean was hailed in the press as a strategic genius and went on to win 3 trophies the following season with his 3 new strikers. Little did we know he was also a mathematical genius. If you'd like to learn about applying mathematical knowledge to finance, then get over now to Finlingo.com, where you can get access to our financial analysis exam tool, which provides infinite questions to help you pass financial analysis exams with ease. Finlingo. Speak finance fluently.